Hi everyone. Thank you for joining us for Serverless Security Best Practices. My name is Leah Vader and I'm a Senior Solutions Architect here at AWS. So today we're going to start off with an overview of what serverless security really is. Next, we're going to look at a couple models for you to consider. Then I have a few use cases that we're going to apply best practices to. We're going to do this by applying a defense in depth approach by layering multiple security controls. But first, let's start with some quick prerequisites. This is a 300 level talk, so we're assuming you have a basic understanding and have worked with some serverless services such as Lambda, API Gateway, DynamoDB, etc. There's also an assumption that you understand some basics of security like identity and access management, encryption, and other AWS controls. I'm going to show some configuration in CloudFormation for a few of these best practices, so some general familiarity with CloudFormation and SAM is also helpful. But as promised, let's start with an overview of security. This is the AWS shared responsibility model. You may have seen this before. It outlines what AWS is responsible for versus what you, the customer, are responsible for. And simply put, AWS is responsible for the security of the cloud, while you are responsible for the security in the cloud. However, this diagram is specific to serverless applications. And there's a larger portion of the diagram that AWS assumes. That doesn't mean that serverless security is free, but this is definitely one of the primary benefits of serverless. As shown, the customer is still responsible for securing data, managing the application, internet access, permissions, monitoring, etc. So let's discuss how to model this. You can take traditional approaches for thinking about securing your application. We just covered the shared responsibility model and how that's different. So the way you think about serverless security is going to be just a little different too. And I'm going to show you a couple ways to think about that. First, you may have heard of the OWASP Top 10. It is the de facto guide to understand the most common application attacks. The risks are selected and prioritized. And the OWASP Serverless Top 10 gives the same insight into serverless applications. This covers risks like injection, broken authentication and access control, sensitive data exposure, etc. I'm not going to step through each and every one of these because we're going to be covering them later. But I do have a link at the bottom for you if you want to learn more. You may also be familiar with a well-architected framework. It's a framework that provides guidance to help developers build and deploy applications following best practices. And there's a pillar specific to security that has these 7 design principles. You may notice some overlap with the OWASP Serverless Top 10. For example, risks like broken authentication and broken access control correspond to implementing a strong identity foundation. So you can find a link to read more about the security pillar and also a link to the serverless lens, which is an approach specific to serverless applications. And today, we're going to take these principles and break them into 4 categories and apply these to a few use cases. First is authentication and authorization, as we do need to have a strong identity management and access control. Next, for our use case, we need to think about data encryption and integrity. We're going to look at the data flow and identify where we can encrypt data in transit and at rest, and where we should be considering to preserve the integrity of data. Then we're going to ensure we have sufficient logging and monitoring through our architecture, and talk about the native logging features you should be looking at. And lastly, for externally facing services, we need to think about the risk of denial of service. Now with serverless services, they scale quite well, but you still want to think about how you protect your backend services and avoid any unnecessary invocations. And for internal facing services, you want to think about how to protect them from external sources. So let's cover our first use case. It's an externally facing API. And here's our architecture. most of you have probably built something just like this. I've built hundreds. And the data flow just looks like this. We have a request. It's sent to API Gateway, which calls a Lambda function or any number of Lambda functions. And these functions may read or write to DynamoDB, RDS, or S3. It's pretty simple. Now let's step through those best practices that we just talked about a minute ago. So the first is implementing authentication and authorization mechanisms. So what should we consider here? When we're considering authentication and authorization, we want to ensure we're using the right mechanism for our use case and for each component in our application. We need to implement the principle of least privilege and take advantage of the fact that Lambda allows us to break up our code base into single-purpose functions and therefore implement fine-grained policies for each function. Lastly, our functions need to access secrets and API keys, so these secrets need to be stored securely. So this applies to the OWASP Serverless Top 10 broken authentication and broken access control, as well as the well-architected frameworks implement a strong identity foundation and apply security at all layers. So our first stop in our architecture is to look at authentication, authorization, and API Gateway. So API Gateway has multiple mechanisms to control and manage access to your API. It provides fine-grained authorization, as granular as authorizing decisions per caller at the combination of unique per path or per method level. And you have a few options for identity providers. The first two, Cognito user pools and JWT authorizers, can validate standard OpenID Connect or OIDC or OAuth 2.0 tokens without any extra code. So API Gateway itself supports the parsing of and handling of any bearer token and can support native parsing of standard OpenID Connect and OAuth 2.0 JWT tokens with the JWT authorizer. So with the JWT authorizer and Cognito user pools, you can authenticate a user by validating tokens through checking the issuer, client ID, timestamp, signature, and authorization scopes when specified. And this would be for any IDP when you're using the JWT authorizer or specific to tokens from Cognito user pool. So next, let's talk about IAM-based authorization. So this provides you with the ability to enable your service to authorize requests in the same manner that all AWS APIs do. The client will have AWS credentials, and there'll be a policy tied to that, giving them permissions that allow for fine-grained access control. And then lastly, we have Lambda authorizers. This is our most flexible authorizer. It allows you to trigger a Lambda function to perform validation using your own custom business logic, and then return an IAM policy and also cache that policy for further requests. So high level, that's how each of them work. But we need to find the right mechanism. So you might use Cognito user pool authorizer if you're currently using Cognito for your user directory. Now, if you're using API Gateway's HTTP APIs, you have the option of using the native JWT authorizer. And this is a good option if you simply need to allow or deny a request based on a token validation and the scopes in the token. IAM authorization is the best option for any client that has or can obtain IAM credentials. This allows you to take advantage of AWS SigV4, where every request is individually authenticated. And when you call AWS APIs, you're using the same SigV4 protocol. You are also managing policies the same way you do in IAM. This is a great option for internal, like service-to-service calls. And lastly, the Lambda authorizer, as I mentioned, is the most flexible. It's available on REST and HTTP APIs, and you can add your own custom business logic, or you can write your own code and simply validate a token and generate a simple policy. I want to dive a little bit more into this one, since it's a good fit for our use case of an externally facing API. So let's step through this whole flow. First, the user authenticates with their identity provider. This is happening outside of the API gateway. The client's given tokens, JWT token as an example. The client then makes a call to API gateway and passes the token in the authorization header. And you can see that there. It starts with bear, space, and then your token. API gateway will first check its cache and see if there's a policy stored there for that token. If not, it invokes your Lambda authorizer function. And if you're unsure about how to write that function, I actually have a link at the bottom for you. We have some great blueprints that can get you started with some boilerplate code, and then you just add your own custom business logic. So we invoke your Lambda function, and this is your code. You can validate the token, you can call your identity provider, or you can do something like perform a lookup to DynamoDB and determine if it's authorized. Next, your function needs to return a fine-grained IAM policy. This will be specific to the client and will determine what paths or methods this client has access to. It can also return context to your downstream Lambda functions or an API key that can be used for throttling. And this makes it so that your client doesn't have to pass an API key. API gateway will then validate that policy against the request and either allow or deny the request. And if allowed, it'll invoke your Lambda function and then cache that policy according to your configuration for later requests. This prevents any additional Lambda authorizer invocations that are potentially unnecessary. So you might be wondering, how do I configure this? So in the console, you just first create your authorizer, and then you attach it to your methods. So here we're creating an authorizer, we're giving it a name, we're pointing it at our Lambda function, we're giving it an invoke role, so API gateway can invoke the Lambda function, then we're specifying the authorization header in this case, and then our caching configuration. And while the console gives a good visualization, it's a best practice to build and deploy your serverless applications using infrastructure as code. So I want to show you how to configure this using a SAM template, which is the transform on CloudFormation. I want to call your attention to these two boxes. The bottom box is the configuration of the authorizer. And notice that I've made this the default authorizer for the API. And the other configuration is just like the console. We specify our Lambda function, the function arm, and the payload type, which is a request. This is a request authorizer. And then also the headers, which is the authorization header. And you'll also notice on my serverless function for the event, I'm specifying the authorization header there as well. So let's move on to more access control and talk about cross-origin resource sharing, or CORS. As a developer, we have all probably struggled with this one. So cross-origin resource sharing, or CORS, defines a way for client web applications that are loaded in one domain to interact with resources in a different domain. And since CORS can be very confusing, sometimes developers allow all access with a star for permission setting. But this is a security talk, and we're not going to call that a best practice. So with API Gateway, you can restrict which headers and methods are allowed and what origins domain is allowed through. So you can configure least privilege. So if you need help with that configuration, because it can be confusing, our developer advocate team actually created a really cool tool called CORS Configurator. It'll help you configure CORS on API Gateway REST and HTTP APIs. And I have a link there at the bottom for you. So moving on to Lambda, we need to consider authorization. So let's start with understanding the function policy and the execution rule. So this may look familiar if you've gone through a Lambda talk before. On the left-hand side, we have the function policy. So this defines who can invoke the Lambda function. And in our case, it's API Gateway. On the right-hand side, we have our execution role. And this is the role that Lambda service assumes, and you'll have a policy attached, and it determines what your Lambda function can do. And in our case, it needs to write to DynamoDB. So to create that policy, you can simply call an API called add_permission. You specify the function name, the action, which would be invoke, and the principal, which in our case is API gateway. And then it creates a function policy like this. I just showed you how to create this via the add_permission API, but tools like SAM or the console will create the proper roles for you. I also want to point out that you can specify a full ARN. So with API Gateway, you can actually specify down to the method level. So let's move on to the execution role. This is a really important topic. The execution role is an IAM role that's assumed by the Lambda service. And in our case, the Lambda function needs permissions to call DynamoDB put item and update item and batch write item. So this is your opportunity to ensure that each function has an appropriate policy for the API actions it needs. And we also want to make sure we're following the principle of least privilege. As such, we do not recommend that you wildcard permissions. So in this policy's case, if we did DynamoDB star, that would give the function permissions to perform any operations, including delete. It is important to note that the Lambda service may assume the execution role to perform certain control plane operations. So things like sending logs to CloudWatch or traces to X-Ray. It will need permissions to do so. So make sure you also include those. Now let's talk a little bit more about least privilege. I want to give you a visual of what we mean when we say use smaller functions and apply least privilege. To ensure adherence to the least privilege principle, we recommend that each function has its own unique role and that it's configured with a minimum set of permissions it requires. So get users should only have read permissions and not share permissions with opposed to get users. And you might be thinking, great, I get the concept of least privilege, but I struggle to get my IAM policy right. So we have a solution for you. SAM has a list of policy templates that allow you to scope the permissions of the resources that are used by your application. Here's an example of DynamoDB write policy, which gives write-only permissions to a specific DynamoDB table. So what this means is these two lines turns into this policy. So let's cover some more access control, because sometimes our functions need access to secrets or API keys, and there are a number of ways to handle this. You can store them in environment variables in Lambda, and Lambda does encrypt these by default. But they're also accessible to anyone who has permissions to the function. And ultimately, when you're using environment variables, you're managing your secrets on a per function basis, and that's going to become very hard to manage. Ultimately, you want to manage these using a secrets management tool like AWS Secrets Manager. Then you can scope permissions to exactly who needs access to these secrets, as well as rotate the secrets. So in our case, our Lambda function can fetch credentials for the RDS database from Secrets Manager and make a connection to that database. Another option for your Lambda function to connect to Aurora is to use RDS Proxy. RDS Proxy offers connection pooling, but it also allows you to enforce IAM authentication to the database, even if that database is using native password authentication. And we really recommend you use these security features instead of managing database credentials in your application code. And then RDS Proxy will use Secrets Manager to get credentials to the database. So we're through our first best practice. Let's do a quick recap. We want to make sure we're using the appropriate authorizer for API Gateway for our use case. And remember, Lambda authorizers are the most flexible. HTTP APIs support native JWT authorizers, And so these two make a lot of sense for externally facing APIs. We also want to follow the least privilege model. And to help you do that, utilize SAM templates in your SAM templates or CloudFormation templates. Next, we need to ensure that we're storing secrets in something like AWS Secrets Manager and enforce least privilege access to secrets via IAM. And then we want to make sure we rotate our secrets regularly. And lastly, we want to use RDS proxy for connection pooling and IAM authentication to the database. So moving on to best practice number 2, which is data encryption and integrity. What we want to consider here is, 1, we need to have a data classification policy. And then we want to ensure that we're only storing sensitive data where necessary. And then we need to look at our data flow and make sure we're protecting data at rest and in transit. And we should be using managed services for key management and that also store secrets as well. Next, we need to consider the integrity of our data and protect against common web exploits like SQL injection, cross-site scripting, and then follow secure coding practices. So this applies to OWASP serverless top 10 injection, sensitive data exposure, and insecure deserialization. And for well-architected framework, this applies to protect data in transit and at rest, and applies security at all layers. So let's start with protecting our data at rest. So our first stop in our data flow is API Gateway. And the only place where you can store your data is in the API Gateway cache. So if you are using caching in API Gateway, we'll want to ensure it's encrypted. So let me show you how to do that. So in your SAM template, I want to call your attention to a couple things. 1, you enable cache at the stage level. So you'll notice we have cache cluster enable set to true, and then our cache cluster size. And then the actual cache data encrypted parameter is a method level setting. And so I have an example here of for all paths, notice the resource path, for all gets, we are encrypting our cache. So moving on, we now need to look at Lambda. So in Lambda, you can store data environment variables, and those are encrypted by default. And of course, Lambda encrypts files that you upload, like your deployment packages and layer archives. But for you, in terms of what you'd be storing, the only data store would be /temp. So first off, be thoughtful about storing it in /temp if the data is sensitive. But if you need to, you can encrypt client side. So whether you do this in Lambda or outside Lambda, you can take advantage of the AWS Encryption SDK. It's a client-side encryption library, and it's designed to make it easy for developers to encrypt and decrypt data following best practices. And you can see a small snippet in Python of calling encrypt. So the AWS Encryption SDK uses envelope encryption to protect your data. That means you're encrypting your data with a data encryption key, then encrypting the data encryption key with a wrapping key. And you do this by specifying the master key provider, which again you can see in that code snippet. You can encrypt the data key under multiple wrapping keys. You may want to provide different wrapping keys for different users as example. And we also provide multiple languages. And I have a link to the Python SDK below. So moving on to our data stores. So by default, all DynamoDB tables are encrypted. There's no option to enable or disable encryption. However, you can select an option to encrypt tables under your own customer managed key. And I actually have an example of that in CloudFormation. RDS can encrypt your RDS database instances. And data that's encrypted at rest includes your underlying storage for database instances and backups and replicas. we have an example here of choosing the storage encrypted parameter in CloudFormation for your Aurora cluster. And lastly, S3 supports default encryption. So you can set the default encryption behavior for an S3 bucket so that all new objects are encrypted when they're stored in the bucket. And these objects are encrypted using server-side encryption with the S3 managed keys or KMS keys stored in the key management service. And I have an example of that here. So now we need to think about protecting our data in transit. And all AWS endpoints are over HTTPS. Now you need to think about your relational database and ensure that you're still connecting to your relational database like MySQL via TLS. So let's move on to performing data validation. So there's a couple ways of doing this. The first is via API Gateway. So API Gateway can perform some basic validations. It can check for parameters, query strings, and headers, and that they're present and non-blank. And then it can check that the payload complies with your configured JSON schema request model. So let's show you an example of this. So here we have an obviously bad request. It comes in, API Gateway checks it against our model, and then denies the request. And when the request is valid, it comes in, it's checked against our model and allowed. So moving on, to protect the integrity of data, we need to also protect against common web exploits like SQL injection. And AWS WAF gives you control over the traffic to allow or block to your web applications by defining customizable web security rules. And WAF integrates directly with API Gateway. And so WAF released support for AWS managed rules to help you get started and quickly. The idea behind managed rules is that we would cover the common attack vectors, so you don't spend a lot of time managing basic sets of rules. And these rules are managed by our threat research team, which is an extension of our DDoS response team from AWS Shield. The rules are influenced by the top 10 security risks identified by the OWASP community. And we've got an example of a screenshot from the console on the right-hand side there. So moving on to your Lambda functions. Here we're going to look at input validation and general secure coding practices. So some examples of good coding practices include ensuring that the input conforms to the type expected. In other words, check for integer versus string. And ensure that you only process known and expected input. For example, the service should only parse known JSON keys rather than iterating over all the keys within a given JSON blob. You should also ensure that you are performing safety serialization in your code, and you can check the OWASP cheat sheet to learn more. And lastly, we need to manage the application dependencies. Attackers can exploit known vulnerabilities found in dependencies, regardless of what programming language you used. So you can do vulnerability scans. And there's several commercial and open source solutions out there. And I've leaked the OWASP dependency check. And this can integrate into your CI/CD pipeline, which is another best practice to implement. And then you want to remove any unused dependencies. And DepCheck is an example of a tool that can help identify any unused dependencies. So let's do a quick recap on data encryption and integrity. First, we need to have a data classification policy. And then, of course, minimize any storage of sensitive data. And then we need to look at our data flows and protect data at rest and in transit. And that means we encrypt at each layer and ensure that we're using native features to do so. And anything client-side, we can use the AWS Encryption SDK. And all AWS endpoints support TLS, but anything that's non-AWS, also ensure that you're using TLS. We also want to use managed services like AWS KMS and Secrets Manager. And then WAF to protect against common web exploits. And of course, in our Lambda functions and API gateway, we need to be performing input validation. And then lastly, checking for vulnerabilities of our dependencies, and ideally within our CI/CD pipeline. So let's move on to best practice number 3. So this is monitoring, logging, and configuration management. So what should we be considering here? We want to use native monitoring tools to identify and report any unwanted behavior. Examples of that are things like wrong credentials, unauthorized access, excessive invocation of functions, and unusually long running time, so like high duration of our Lambda functions. We also need to ensure logging is enabled for all components and avoid logging sensitive data. And then lastly, we want to perform regular auditing of our configuration. So this applies to OWASP serverless top 10 security misconfiguration and insufficient logging and monitoring. And it also applies to the well-architected frameworks enable traceability and apply security at all layers. So, first service we want to look at is CloudWatch. So there's a few components to CloudWatch. We have metrics, we have alarms, we have dashboards, and we have logging. So metrics are for each individual service. So like Lambda, this would be things like duration and invocations. And API Gateway, it would be like 5xx errors and latency. And so we want to continue to monitor and alarm on our important metrics. And like we mentioned before, we want to make sure we monitor things like excessive invocations and alarm on that, and potentially like long durations for your Lambda functions. And we can create dashboards so we can have a single pane of glass of our full serverless application. And then lastly, logging is going to be so important. So let me show you where we can log in our architecture. So API Gateway allows for access logging. It does also allow for execution logging for additional debugging, but this isn't something you want to be running in production. You want to use execution logs for debugging in your development environments. Next, you have logging in Lambda through CloudWatch logs. Lambda automatically sends logs to CloudWatch, which is why you need to have permissions in your execution role for CloudWatch. DynamoDB, you interact with via API, so logging there is via CloudTrail. RDS supplies database logs and also supports CloudTrail, and S3 supports access logging. So I want to show you how to turn on access logging API Gateway. And there's a few key points I want you to look at here. That first box there, the retention in days, I've set it for 30, but the default's actually indefinite. So you want to ensure that you set that to something that makes sense for your application. And lastly, you'll notice for your access log setting, you'll send it to the destination ARN for CloudWatch. You can actually also specify your own format as well. Next is CloudTrail. So this gives you a history of AWS calls into your account, including API calls made through the management console and any API like CLI, SDKs, etc. CloudTrail is important for all AWS resources, not just serverless applications. And it's a best practice to turn on CloudWatch in all AWS accounts in all regions. Next, we want to talk about config. So when you turn on AWS config, it begins recording any configuration change, as well as compliance violations from preset rules. So this is what their dashboard looks like. It is a configuration auditor, and it monitors configuration over time. And it evaluates that against a set of rules. And so, for example, if your API cache is not encrypted, you could trigger an alert and remediate. You can write your own rules, but there are managed rules out there that you can take advantage of. And here's some examples of managed rules for Lambda, and API Gateway. Lastly, X-ray is the last part of your observability that you need to take a look at. And X-ray gives an end-to-end view of requests as they travel through your application. So this is important to you because it shows a map of the application's underlying components so you can quickly understand the system you're working with and how those components correspond to each other. So let's do a quick recap. We want to make sure we're using monitoring tools like CloudWatch and CloudTrail to identify and report on any unwanted behavior. But we also need to make sure that we have sufficient logging for all components in our application. We want to make sure we also avoid logging sensitive data and debug logging in production. And then lastly, we need to perform regular auditing of configuration using AWS Config. So let's move on to best practice number 4, which we're going to focus on denial of service, since this is an externally facing API. So we need to think about DDoS protection, throttling and rate limiting, and network boundaries. So first, we're adding AWS Shield and CloudFront to this architecture. So Shield's a managed distributed denial of service, and this couples with CloudFront. So CloudFront's our CDN. And between Shield, Standard, CloudFront, and Route 53, you receive comprehensive availability protection against all known Layer 3 and Layer 4 attacks. But since we added CloudFront to this architecture, I want to call out our different Amazon API Gateway endpoints. Because another thing you need to think about is having the proper endpoint. So we do have an edge optimized endpoint, and this has a managed CloudFront distribution in front of your API Gateway. So it's not something that you can configure on your own. And there is no caching. It's only used for endpoints. And what we would recommend if you're going to put CloudFront in front of API Gateway is to actually use a regional endpoint. And we generally recommend this for all use cases for API Gateway if it's public facing. And then the last one is the private endpoint, which we'll get to a little bit later, but it's only accessible within the VPC. Now I should add, if you're using CloudFront also supports WAF, and therefore you should configure that there rather than in API Gateway. Our next step is we need to configure throttling in API Gateway. So you want to configure throttling in API Gateway just to prevent your backend from being overwhelmed. So this could be a Lambda function or any other service. And API Gateway throttles using the same token bucket algorithm that you're used to. This is how we do throttling on our own APIs. So let's talk about how we can throttle in our account in our APIs. So I'm going to actually start on the right-hand side where it says per account in purple. So first, there's an account level quota. All APIs in the account share this. You can ask for an increase. Next, you can configure throttling per stage and per method. This is at the API stage level. Now, if you implement usage plans, you can throttle per client with an API key. And then you can get even more granular and throttle per client and per method. So let's recap. So to defend against DDoS attacks, you want to make sure you're using CloudFront, Shield, and Route 53. And then you also always want to implement throttling and rate limiting through API Gateway. So let's move on to use case number 2. This is service-to-service calls. So I'm going to talk about 2 different types of service-to-service calls, because sometimes you have services, potentially vendors or partners outside of AWS, or potentially devices that need to call API Gateway. So I'm going to focus on that one first. So if we look at authentication for these vendors, partners, maybe devices, MTLS might be a good use case. So API Gateway supports certificate-based authentication via mutual TLS, also known as MTLS. And this is where both parties are authenticated via certificates with TLS. So you can configure MTLS on the custom domain to authenticate both regional REST APIs, remember the endpoints that we talked about before, and HTTP APIs, while still authorizing requests for Bear or JWT tokens or signing requests for IAM-based authorization. I mention this because MTLS is providing authentication, but not authorization. So let's walk through how you might configure this. First, you're going to prepare a PEM encoded trust store file for all certificate authority public keys you want to use with MTLS. Then you're going to upload that trust store file to an S3 bucket in the same AWS account as your API gateway. I do want to note that it's recommended that you turn on versioning in your bucket. Next, here in the console, we can go ahead and enable MTLS. So mutual TLS, turn that on, and TLS 1.2 is required. And then we're going to point it to the S3 location of our trust store bundle and specify our S3 version. And this is how we do it in SAM. So note that this is configured in the domain property. And again, we specify the location and the version, and then set the security policy to 1.2. So the last part is you want to disable the default endpoint. And let me show you why. So you just configured a custom domain, right? And our clients can go to api.example.com. But they can also go to the default endpoint, which is that execute API endpoint there at the bottom. But mutual TLS is configured on the custom domain. So if the client points to the default endpoint, there's no MTLS configuration. So we need to disable that endpoint. And that's as easy as clicking a radio button in the console under Settings in API Gateway. Or alternatively, you can call update REST API and change the setting disable execute API endpoint to true. So you may be familiar with this flow. The client will request a resource, the server presents its certificate, the client verifies that certificate, the client presents its certificate, then the server verifies that client certificate. Now where we leave off is we can pass that certificate to a Lambda authorizer, because you may have noticed in that flow that we have not yet checked to see if the certificate's revoked. So this is what the authorizer event looks like, and this is for the V1 payload on the REST API. And you can see it's part of the request context. So your Lambda function can validate certificates against a certificate revocation list, or make a call to an online certificate status protocol server, or OCSP server, and request validation that that certificate's still valid, and then return the response back to API Gateway. So that covers MTLS. But for internal services running within AWS, we likely want to take a different approach. So for this, we recommend IAM authentication. So like I mentioned before, this uses the same SIGV4 signing as AWS services. And SIGV4 authenticates each request individually. And if that signature is ever compromised and reused later, the request would no longer be valid. So this is a big benefit. On top of that, the authorization strategies delegated to a dedicated service, and you have centralized access management to a single set of policies, and roles and credentials can be disabled with a single API call. So this is the most secure authorization option, but it does require that your clients understand how to sign requests. But you're doing it today with the AWS SDK, and you can also provide your clients with an SDK with request signing built in. So let's expand on our internal service. We assume Lambda needs to connect to RDS, And this time we're going to include RDS proxy for IAM authentication. So like moving down our best practices, we just covered best practice 1. We're going to use IAM auth on API Gateway. For best practice 2 and 3, those actually still apply for our internal microservices. So now we need to move on to 4 and focus on infrastructure protection and how to protect our internal service now. So let's start with API Gateway, because we want to make this now a private endpoint. So private endpoints restrict access to services and resource inside your VPC. And how this works is we use a VPC endpoint for API Gateway. So your microservice calls the VPC endpoint, which sends a request to API Gateway. We're also attaching a resource policy to API Gateway to limit access to allowed VPCs or VPC endpoints. So I want to show you how to configure that. First, if you don't have a VPC endpoint today, this is the CloudFormation to do so. So you're going to create a VPC endpoint. You'll notice the service name is execute API. And then we're going to create our serverless API, and we're going to specify the following endpoint configuration. It's going to be private, and then we're going to reference our VPC endpoint that we just created. And then lastly, if you recall, I mentioned you need to have a resource policy. And with this resource policy, we're going to restrict access to our API gateway. And we're going to restrict it to, in this case, our VPC endpoint. So you'll notice here, I have this intrinsic VPC whitelist. So SAM makes this easy. I can specify intrinsic VPC whitelist or intrinsic VPC E for endpoint whitelist, IP ranges, etc. And it makes it very easy to create that VPC endpoint policy that I created above. So that covers our internal API. Let's talk about Lambda communication to RDS proxy, because that's happening in a VPC. First and foremost, I want to be clear that Lambda functions run in a VPC, but it's the Lambda service VPC. So when a Lambda function is VPC enabled, the Lambda service creates a network interface in your VPC for functions to use. And the same functions that share security groups and subnet combinations will use the same network interface. I should also note that security groups, network ACLs, and routing all apply here. So you really only need VPC-enabled functions to access VPC resources. So this isn't adding any extra layers of security. So let's recap on our infrastructure protection. 1, API gateway private endpoints are used for internal services. And services in other VPCs can access via AWS private link. And then next, VPC-enabled Lambda functions are only necessary when you're trying to access VPC resources. And of course, all VPC routing, network ACLs, and security groups still apply. So let's summarize the changes that we just made, or we just covered with our best practices. With Shield and CloudFront, we have DDoS protection. We're also using WAF roles to cover OWASP top 10, SQL injection, cross-site scripting, that sort of thing. We have authorization, cores, validation, throttling, proper endpoints, resource policies, cache encryption on API gateway. In our function, we're doing input validation and other secure coding practices, as well as implementing a function policy, an execution role. And we're also managing our dependencies by minimizing the amount we have and also doing vulnerability scanning in our CI/CD pipeline. And then we're always encrypting in transit and at rest in our data stores with KMS. But we need the observability and auditing piece as well. So we're using CloudWatch for metrics, logging, alarms, dashboards, CloudTrail to record all AWS API calls, config to record all configuration changes, an X-ray to get a good view, a service map of all of our applications so we can quickly understand the data flow and how they work. So I just threw a lot of information at you. I'm well aware of that, but I want to give you some resources. So one, we have our OWASP Serverless Top 10 and our security pillar for well-architected serverless application lens. And the last one is a set of serverless samples that have implemented a lot of the best practices I just talked about. So please go check that out. There's a lot of good resources and information in there and a lot of code samples that you can copy. So I really hope this was helpful, and thank you so much for watching.